We have been studying trig functions for a while now, and in our study of trig functions, we haven't actually stopped to pause and say, okay, well, these are functions, right? Functions are relations, relations have domain and range. So what are the domain and range? Okay, so remember, when we talk about the domain, that is telling us what values it's defined for, in essence saying when we are able to use them. And then when we talk about range, range is, the outputs. So it's telling us, okay, when we use them, here's what we get, right? So let's think about our definitions just a little bit, okay? So if we think about sine, for instance, okay, we want to think about the domain and range for sine, okay? And we saw originally that we had sine as a function of arc length. Later on, we said sine could be a function of the angle, central angle on the unit circle as well. So then the question now is, what is the possible domain and range of this function? Okay, and I'll just kind of draw the unit circle for reference again. Okay, so here's our unit circle. I'll just label the points 1, 0, 0, 1, -1, 0, and 0, -1. Okay, so domain. Domain is a set of all inputs. Okay, so I'm thinking t or theta. Okay, well, the question is, what values of the arc length could we have? What values of the angle could we have? Personally, I think it's easier to think about it in terms of an angle. Okay, so again, if I'm thinking about a central angle, okay, so again, I would start measurement here, and then, this radius, right, would spin around from initial side to terminal side, and the space in between would be our central angle. So my question is, where would this angle measurement begin and stop? Like, what are the boundaries? Well, you might be tempted to say 0 to 2 pi, right, inclusive on both, right, because that would be one circle, right? Um, in reality, that's incorrect because the angle, right, like I can keep on going around the circle forever and ever and ever, so I could go around it as long as I wanted to, right, in the counterclockwise fashion, and that would just take me up to infinity. In the same way, I could go around the circle counter or clockwise, which would be the negative direction, as much as I wanted to as well for the angle. So that makes the domain all possible angles, all possible arc lengths, negative infinity to infinity. Okay, and again, we're thinking domain is all about that input. Now I want to think about the output, right? We know the output for sine, so sine of t was always y over 1, okay? 1 isn't going to change, so really and truthfully, we're just saying sine of t is y, okay? So then I'm thinking, okay, what are possible values for y when I'm on the unit circle? Okay, I'm looking at the unit circle, and I'm saying, okay, well, I know it's like 1 is a possibility, -1 is a possibility. Can I have anything in between? Well, yeah, I have 0, right? And in reality, I have everything in between it as well. So the possible y values here is going to be the range because I'm looking at y's, or the output of sine is y, and so the range here is -1 over 1, or -1 to 1, inclusive on both. Okay? The domain and range here for sine end up being exactly the same for cosine. Okay, so cosine will have a domain that is minus infinity to infinity and a range that is -1 to 1. But again, cosine is looking at, for its output, x over 1, right? So cosine of theta is equal to x over 1. But instead, we're saying that x values that occur for the output of cosine are -1 and 1, as well as everything in between. Okay, so the range here is -1 to 1. Okay? Domain is also all real numbers. All right. Some interesting things happen with the other trig functions, right? We end up saying, we have kind of some restrictions on them, right? Because we end up dividing by 0, okay? So then we have to be a little bit more careful with other trig functions. Secant is one of which where we need to be a little bit more thoughtful, okay? So for the domain, we know that x cannot be 0. All right, that's fine, but that x actually has no bearing on this because remember that our input is t, right? So I'm trying to figure out where, or maybe if this is instead like a function of theta, right? This is asking the question, what angles have an x-coordinate of 0, okay? So then I would have to go to my unit circle, look at that, and it actually ends up being the case that like theta equals pi over 2, 90 degrees, has an x-coordinate of 0. 3 pi over 2 does as well. And then if you keep going, be 5 pi over 2, 7 pi over 2, 9 pi over 2, you start to see the pattern here, so on and so forth. And it also goes in the negative direction. So the way we represent the domain would be using set notation. It's a little weird, but we read this as all, let's do it in angles, all theta, or all angles, such that theta is not equal to pi over 2 times, and here's how we represent that odd piece, 2k plus 1 for k in integer. So that's how we would represent the domain of secant, okay? All the places where, we have an x-coordinate of not 0, okay? Range is a bit trickier with the other functions. Range. Honestly, the best way to find the range is to look at a graph. Here, what happens if you think about secant being, let me do this in a different color. Secant, we said, was 1 over x, right? And we said the x-coordinate is, x is really between -1 to 0 union 0 to 1. Okay, and so if you take 1 and divide it by effectively a fraction, right, it's going to blow it up negatively if it's a negative number, or positively, and these are actually hard brackets, square brackets. Right, if you have 1 divided by a half, that's going to be 2, so that's why the range ends up being off to infinity, because you could get, really close to 0 but not 0, and that's effectively infinity. Okay, so range gets to be a little bit more tricky, and the big takeaway is when you're working with domains of trig functions, it isn't necessarily x's and y's in that sense. It's thinking about what possible angles could I have for the input, and then what are the possible outputs in terms of ratios. Okay, so be sure to be careful when finding domain and range of trig functions.